video is on Unit 3, Chapter 7 on rational exponents and radical equations. Lesson number 1 is on radicals and roots. This lesson should be fairly familiar because we have worked on simplifying square roots, and this is going to include some cube roots and fourth roots and fifth roots and so on. The warm-up here I've already filled out. It asks us to list the perfect squares, perfect cubes, and perfect fourths. So let's talk about just perfect squares. Perfect squares come from squaring the number. So 1 squared is 1. 2 squared is 4. 3 squared is 9, and so on. 4 squared is 16. 5 squared is 25. So that gives us those perfect squares. 1, 5, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, ... because it just keeps going. 11 squared would be 121. So there's another one. Okay, so those are all perfect squares. It would be in your best interest if you could identify them, at least some of them, on site. Perfect cubes are created by cubing a number. So 1 cubed is 1. 2 cubed means 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216, and so on. So the 1, 8, 27, 64, 125, 216, 343, 5, 12, 729, ... Those are all referred to as perfect cubes because they have a nice, pretty, perfect square. If I take that 729 and I do the cube root, so to go to math, select number 4, the cube root. Let me start that over. Math, cube root is number 4 of the 729, and that's going to give me 9. So that tells me that 9 times 9 times 9 is 729. Now for your perfect fourths, 1 to the 4th power is 1, because 1 times 1 times 1 times 1 is still 1. 2 to the 4th power means 2 times 2 times 2 times 2, which is 16. 3 to the 4th power is 81, and so on. So the numbers I have listed here, the 1, 16, 81, 256, 625, 1296, and so on, are numbers that we refer to as perfect fourths. And again, it wouldn't be a bad thing if you could recognize some of those. In the next section of your notes, it talks about the parts of a radical. The nth root of a real number a can be written as the radical expression nth root of a. The index here is the little number that we include on the radical sign. So if there is no number there, if there is no index, it is assumed that n equals 2, which is why when you see the sign just by itself, you say square root, because square is associated with 2. So the understood index is 2. The symbol is called the radical sign, and then the number that's under the radical is called the radicand. So let's look at this next set in our notes. It says, give all possible roots to the radicals below. So the square root of 16 can be a positive and a negative 4. And we learned that when we studied the square root property. When we square root a positive number, it can be a positive or a negative 4. Square root of 121, same thing, positive or negative 11. Square root of 289 is a positive or negative 17. And the square root of 4/25 is a positive and a negative 2/5. And that's for a square root. Let's jump down to the next row. It says the cube root of 8. So the cube root of 8, let's go to go to math. Cube root is number 4. The cube root of 8 should say 2. Now, because it is an odd index, because the index is equal to 3, it's an odd index. If I say -2 times -2 times -2, that's going to give me a -8, not a +8 like what you see under the radicals. So with these, there's only one possible answer. This can only be a 2. Cube root of 343. Math for 343 says 7. Now look at the next one. It says the cube root of -125. Math for -125, and you're going to find this interesting. It actually pops out an answer. The answer is -5. And then the last one says the cube root of -127. Math for, I'm going to pull up a fraction, -1 over 27 should give me -1/3. And then the last row here is the 4th root of 1. So to do 4th root, we're going to go to math. You're going to select number 5. We're going to have to put in the 4 and then the 1. So I've got the 4th root of 1 is just 1. And you're going to have to trust me on this one. It can actually be a positive and a negative, and I will explain why here in just a second. 4th root of 2401, math, number 5, 4th root of 2401, it says 7. But again, because it is a even index, it can be a positive or a -7. 4th root of 4096, it says 8. Again, positive or -8. And then the 4th root of 81/16, math, 5, 4th root, alpha y equal 81/16 is 3/2. And again, it can be a positive or negative. Now, here's why. I'm going to go back to this 4th root of 1. 1 to the 4th power is 1. -1 to the 4th power. 1 to the 4th power is 1. -1 to the 4th power is also 1. So that's why anytime we have an even index, you have 2 solutions. And if you look at this table that's going to follow, that's the point of that first line. If the index is even, so on that first row of examples, the index was an understood 2. The third row, the index is a 4. And in both of those cases, because it's an even index, we can have 2 real answers. 2 real answers, one being positive and one being negative. Now let's talk about odd. And y'all, I forgot to mention that was if the number underneath is positive. In all of those examples, the number underneath is positive. What if I have an odd index? So that's that second row of numbers. We're looking at that second row of numbers. The index is odd. If the number underneath is positive, then we're going to have one real solution, and it's going to be positive. So if you look at that cube root of 8, the only answer it could be is 2. It can't be -2. It can only be a 2. If the number underneath is negative, like on the cube root of -125, again, we're only going to be able to have one answer. And the answer, if the number underneath is negative, the answer is negative. What if, on this last row, the index is even, but the number underneath is negative? that's when your imaginary numbers are going to come into play. And again, it's still 2 positive and a negative, but you're going to have an I. You're going to have an I. All right, so let's keep going here. We want to simplify these radicals. In this next section of your notes, it says if a radical has more than one root, the radical sign indicates only the principal or positive root. So in this lesson, I'm not worrying about all the pluses and minuses. We're just trying to simplify these numbers. All right, so I got the square root of 117. Again, the understood index here is a 2. So to do this, just like we've always done, we're going to go to our calculator. We're going to go to y equal 117 divided by x squared. And it's divided by x squared because the understood index there is a 2. Go to the table, just like we've always done. We're going to look for where the y's cross over to 0. Go up to the first whole number, which is a 13. And this is 3 times the square root of 13. Number 2, a little more complicated. There's a 4 in front. So we have to make sure we say 4 times whatever else is going to come out. Again, the understood index here is a 2. So we're still going to go to the y equal 320 divided by x squared. Go to the table. Look for where the y crosses over to a 0, so it becomes less than 1. Go up to the first whole number in the y column, which in this case is a 5. So 8 times the square root of 5. And to finish this off, we have to make sure that we multiply the 4 times the 8, which is 32, times the square root of 5. Number 3 and number 4 are slightly different because what's the index on number 3? The index is 3 because that's that little number there. So the steps are going to be similar. There's a 2 out front, so I'm still going to multiply 2 times whatever the calculator gives me. But taking that 48, we're going to divide by x cubed instead of x squared. Because the index is a 3, we want to divide by x cubed. But the rest of it's the same. So we need to go look at the y column. It's already crossed over to 0. The first one is a 6. So 2 and a 6. 2 times the cube root of 6. 2 times the cube root of 6. And then don't forget to multiply the 2 times the 2, which is 4. And then also don't forget to write your index in there. Same thing on number 4. 3 times the cube root of 108 means I got 3 times. We're going to take 108 and divide by x cubed. 108 divided by x cubed. Table. There's the zeros. 3 and a 4. So 3 cube root of 4. 3 times 3 is 9 times the cube root of 4. All right, let's keep going. Number 5, I have the cube root of negative 250. All right, so a couple things here. Cube root, the index is 3. It's an odd index. A negative underneath equals a negative outside. There's no I here, y'all. There is no I on 5 and 6 because they are a 3, an index of 3, an odd index. Just means that there's a negative inside, there's a negative outside. All right, so we're going to ignore the negative when we go to put this in the calculator. We're going to take that negative from the inside and put it on the outside. We're going to take 250. Again, leave off the negative. Just take the number, divide by x cubed. Find our answer here. So 5 and a 2. 5 times the cube root of 2. And it's going to be negative 5 times the cube root of 2. Number 6, same thing. There's a negative on the inside, so I'm just going to make that 6 negative. And then it's going to be cube root of, I'm going to tell you right now, there's nothing you can do with that 2. So if we do 2 divided by x cubed, and you go to your, table, all you're going to see is the 1 and the 2. So when you see a 1, when the only thing that's involved is a 1 in the x or a 1 in the y, there's not really anything you can do here when the 1 is the x. It's just the cube root of 2. And then the next two are an index of 4. So when I go to simplify these, I'm going to divide by x to the 4th. Divide by x to the 4th. And FYI, I will never give you a negative in the 4th rate. There will never be a negative under the 4th rate. We're going to have a 3 times something. So we're going to do the 4th root of 162, y equals 162 divided by x to the 4th power. Same exact steps. It's a 3 times the 4th root of 2. 3 times the 4th root of 2 is how we say that. And then don't forget to multiply the 3 times the 3 to get the 9. And that's not a 3. That should be a 4. 4th root of 2. And then the same thing on number 8. We're going to have 5 times 2592 divided by x to the 4th power. And it's going to be a 6 times the 4th root of 2. And then 5 times 6 is 30. All right, continuing on here, this next set is going to be very interesting. It's very important that you know that when we're talking about square roots, the exponent's supposed to be multiples of 2 because the index is 2. If it's a cube root, the exponents on your variables need to be multiples of 3 because it's a cube root. And then for 4th root, again, your exponents must be multiples of 4 on those variables. So let's look at number 9. On number 9, the index is 2. And we're going to just take care of the 32. I'm going to ignore the variables for just a second. So I got 32. I'm going to go to y equal 32 divided by x squared because the index is 2. And it's 4 times the square root of 2. Now let's talk about these x's and y's. If I have x to the 4th, what is 4 divided by 2? It's a 2. It's a whole 2. So that means that all of my x's are a multiple of 2. What that means for us is we're not going to have any x's left under the radical, and we're going to have an x squared in front of the radical. All of the x's are going to square root out. Now let's talk about the y to the 9th. 9 divided by 2, and I'm dividing by 2 because that's the index. That's the index. 9 divided by 2 does not go evenly. 2 times what gets me close to 9? Well, 2 times 4 is 8, right? With a remainder of 1. So what that means is I'm going to have 4 y's on the outside, and that 1 remainder is going to be left on the inside. Let's do that again. Number 10, the index is still 2. I have the square root of 342, a to the 3rd, b to the 7th. So 324 divided by x squared is, I think this one's a perfect square. It is. It's 18. See the one in the y column? It's 18. There's no number left under the radical. Now let's talk about a's. On the a, we have an a cubed. 3 divided by the index is 1 remainder 1. Oops. 1 remainder 1. So there's 1 on the outside and 1 on the inside. What about my b's? I have b to the 7. So we want to do 7 divided by 2. Well, that's a 3 remainder 1. So 3 b's on the outside, 1 b on the inside. Let's keep going. Number 11. Number 11 says the cube root of 216, m to the third, n to the sixth. So my index equals 3. My exponents on those variables need to be in multiples of 3. Let's first do the 216. So y equals 216 divided by x cubed, because again, your index is a 3. And we've got, it's equal to 6. It's equal to, did I do that right? 216. Is 6. Okay, so it's 6. So I have a 6 on the outside. Now, for your m's, your m has an exponent of 3 divided by 3, goes evenly, it goes one time. So we're going to have an m on the outside, no m's on the inside. What about my n's? The exponent on the n is a 6. Again, divide by the index, which is 3. It goes evenly, a 2. So I'm going to have an n squared on the outside. And what happened is there is no radical. There's nothing left under this radical. On number 11, everything underneath there is a perfect cube. 216 is a perfect cube. M to the third is a perfect cube because that exponent's a multiple of 3. N to the 6th is a perfect cube because 6 is a multiple of 3. Number 12, the cube root of 56, r to the 8th, s to the 4th. Actually, yeah. Okay, so 56, cube root of 56 is 2 times the cube root of 7 Now let's look at our r's. You're going to take the 8 that's on the r, divide by the index, which is a 3. How many times does that go evenly? Well, 3 times 2 is 6 with a remainder of 2. So 2 on the outside, r squared on the outside, r squared on the inside. S to the 4th. 4 divided by 3 goes one whole time with a remainder of 1. So there will be an s to the first power on the outside and an s to the first power on the inside. 13 and 14 are just like number 11, except for because there's a negative under and it is an index of 3, there'll be a negative on the outside. Let me do one of these. So number 13 says the cube root of negative 64, x to the 10th, y to the 21st. So let's take care of the cube root of 64. So y equals 64 divided by x cubed. Notice again, there's a 1 in the y column, which means that was a 64 is a perfect cube. It's equal to 4. So in this case, it's going to be negative 4. Odd index, because it's an index of 3, the negative on the inside means there's a negative on the outside. For our x to the 10th, 10 divided by 3 is 3 remainder 1. So I'm going to have an x to the 3rd on the outside and an x to the 1st on the inside. Y to the 21st power, 21 divided by 3 is a whole 7. So I'll have y to the 7th on the outside. Jumping down to number 15 and 16, I have the 15, 16, and 17. We're talking about the 4th root. So the index is 4, and we're going to follow right along. Notice on number 15, there's not a number, but there are just variables. So for the W, I have a 4 exponent. Divide by the 4, that's the index, and you get a whole 1. So there will be a W in front of that radical. For the V, that is a V, 17 divided by 4. 17 divided by 4. Well, that's going to go 4 times, because 4 times 4 is 16, leaving me with a remainder of 1. So V to the 4th power is on the outside, and V to the 1st power is on the inside. And there's the answer to number 15. Let's look at number 17. 4th root of 625. Y equals 625. 625 divided by x to the 4th power is a whole 5. It's just 5. No, nothing left under the radical there. It's a 5. Now for the C's. The exponent on the C is a 23. We're going to take 23 divided by 4. Well, how many times does that go evenly? 5. Because 4 times 5 is 20, leaving me with a remainder of 3. So C to the 5th on the outside and C to the 3rd on the inside. And then for the D's, 11 divided by 4. How many times is that going to go evenly? I'm going to say 2. 4 times 2 is 8. 9, 10, 11. Remainder 3. So D squared on the outside, D cubed on the inside. 18 looks funky. It's not really that weird. Leaving the y plus 3, just y plus 3, it has an exponent of 8, and 8 divided by 4 is a whole 2, which means we have a y plus 3 squared outside of the radical. So there are your notes. Let me just go. Yeah, there are your notes for chapter 7, lesson number 1. Holler if you have any questions.